Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 13th lesson on a given Form 3 mathematics topic called sequences and series. So we are looking at our 8th example on geometric progression, which is a past Kcse equation tested in 2019, paper 2, question number 17. It reads that the first term of an AP is equal to the first term of a GP. Then the second term of the AP is equal to the fourth term of the GP, while the 10th term of the AP is equal to the 7th term of the GP. Then in part A of the question, we are told that given that A is the first term, so this one means that A is the first term of both the AP and the GP, and D is the common difference of the AP, while R is the common ratio of the GP. Write the two equations connecting the AP and the GP. So in the first statement, you are told that the first term of the AP is equal to the first term of the GP. Then you are told that the first term is denoted by A. Therefore, the first term of the AP, it must be equal to the first term of the GP, which of course we are told to use A as the first term of both the AP and the GP. We are further told that the second term of the AP is equal to the fourth term of the GP. Now we know that the nth term of any given AP is always given by the formula A plus n minus 1, then of course into bracket we multiply with D. Then you also know that the nth term of any given GP is given by the formula AR to the power of n minus 1. So we are told that the second term of the AP, so the second term of the AP is equal to, the fourth term of the GP. So this one is equivalent to the fourth term of the GP. Now we know that from this particular formula, the nth term of any given AP is A plus n minus 1 D. Therefore, the second term will be A, then of course plus our n will be 2. So 2 minus 1, then we multiply with D. This one should be equal to the fourth term of the GP. The nth term of the GP is AR to the power of n minus 1. Therefore, the fourth term of this particular GP will be given by A, then of course R to the power of 4 minus 1. When we simplify, we'll get A, then of course plus 2 minus 1, you'll get 1. 1 multiplied by D, you're just going to get D being equal to AR to the power of 4 minus 1, you'll get 3. Therefore, this will become our first equation. Then we are further told that while the 10th term of the AP, so if we take the 10th term of this particular AP, this one is equal to, the 7th term of the GP. So this one is equivalent to the 7th term of the geometric progression. So the 10th term will be given by A plus our n, of course, will be 10, then minus 1, close the bracket, multiplied by D. This one should give us the 7th term of the GP. So the 7th term will be A R to the power of 7 minus 1. When we simplify, we'll end up with A plus, so we'll have A, then of course plus 10 minus 1, you'll get positive 9. Then of course we multiply with D. This one should be equal to AR to the power of 7 minus 1, we'll get 6. So this will be our equation Roman 2. Therefore, equation Roman 1 and Roman 2 are the required two equations connecting the AP and of course our GP. Then we'll move to part B of our question. Let me separate my working using this particular line here. So we've answered part A. So in part B, we are being told that find the value of R that satisfies the progressions, that is both the AP and the GP. So to find that, we'll just solve equation 1 and equation 2 simultaneously. So the first equation was A, then of course plus D, which was equivalent to AR to the power of 3. Then our second equation is A plus 9D. This one was equivalent to AR to the power of 6. So these are simultaneous equations which can be solved by elimination method. So I want to eliminate D, because remember we are required to find R. Therefore, we don't need a D in this particular equation. So to eliminate D, I'm going to multiply the first equation by 9, so that I'll end up with 9 multiplied by D to give me a 9. Remember the coefficient here is 1. So I'll just interchange. The first equation, I multiply it with 9. Then, of course, the second equation, I multiply it with the coefficient of D, which is 1. So if I open bracket, I'll end up with 9 multiplied by A, which will give me positive 9A. Then, of course, plus 9 multiplied by 1D, I'll get positive 9D, being equal to 9 multiplied by AR cubed, I'll get 9AR cubed. Then the second equation, if I multiply with 1, I'll just remain with A. Then, of course, plus 9D being equal to AR to the power of 6. Then when I subtract these two equations, D will get eliminated. So 9A minus A, I'll get positive 8A. Then, of course, plus 9D minus 9D, I'll just get 0, being equal to 9A cubed minus 9 minus A R power 6. I'll get 9AR cubed. Then, of course, minus AR to the power of 6. Remember, these ones we can't separate, we can't subtract them directly because they are not like terms. One is R cubed, whereas the other one is R to the power of 6. So we'll end up with 8A being equal to 9AR cubed, then minus AR to the power of 6. But we realize that A is common in all the terms. Therefore, I can reduce the equation by dividing through by A. I also divide through by A. I also divide through by A, so that A and A will cancel out. A and A will also cancel out. Then, of course, A and A will cancel out. So I'm going to remain with this equation. So I'm remaining with 8 being equal to 9R cubed. Then, of course, minus R to the power of 6. So this equation can be rearranged. So I'll take these particular values towards the left hand side, so that R to the power negative R to the power of 6 will become a positive R to the power of 6. Then, of course, when 9R cubed crosses equal sign, it becomes a minus 9R cubed. Then, of course, 8 was still on the left hand side, so this will be plus 8. Then, of course, on the right hand side, we are going to retain 0. Now, this is a quadratic equation, although we need to do some modifications on it for us to get the perfect quadratic equation. So let me separate my working with this particular line here. So this equation, because I already have an R to the power of 3 here, I can also rewrite R to the power of 6 in terms of R to the power of 3. So I can just take R to the power of 3. Then, of course, I'll take the 2 outside. Remember, from the laws of indices, when I open this bracket, I'll have 3 multiplied by 2, which will still give me R to the power of 6. So I'm separating because I already have an R power 3 here. So I want to give it a common letter. So I continue with the equation, minus 9 R to the power of 3. Then, of course, plus 8. This one is equivalent to 0. So because R to the power of 3 is common, I'm going to give it a letter. So I'll say I will let R to the power of 3 to be equivalent to a certain letter, for example, T. So that means where I have R power 3, I'll substitute with T. Here, I'll also substitute with T. So the equation will end up being T, but of course it is, I have a square on the power, so this will be T cubed. That is T to the power of 2, or T squared, then minus 9T, then of course plus 8. This one is equal to 0. Of course, you can see this is clearly a quadratic equation, so which can be solved using the quadratic formula. So the quadratic formula dictates that, this is in the form ax squared plus bx, then of course plus c is equals to 0. where the value of A will be the coefficient of t squared, of course, which is 1. Then the value of B clearly will be negative 9. Then the value of C, of course, will be positive 8. So the quadratic formula requires that the value of t be given by negative b plus or minus the root of b squared. So I'll have b squared minus 4ac, then the whole thing divided by 2a. So if I substitute, I'll end up with t being equal to negative b will be negative 9, then of course plus or minus the square root of b squared. So my b is negative 9, so this is negative 9 into bracket squared, then minus 4 multiplied by a is just 1, that is the coefficient of t squared, then times c, my c is positive 8, then the whole thing is divided by 2 multiplied by a, of course, which is 1. So that means t will be equivalent to negative 9 will give me positive 9, then plus or minus the roots. Under the root, I'm going to have the following. So 9 squared will give me positive 81. Then negative 4 multiplied by 8, I'll get a negative 32. Then the whole thing is divided by 2. Then let me clean this particular side, but before I do that, let me copy my questions 1 and 2. So these were the answers for part A of the question. The first equation, I got it as A. So this is A plus D is equals to AR cubed. This was AR cubed. Then my second equation, so this was A plus D is equals to AR cubed. Then my second equation was A plus 9D. This one was equivalent to AR to the power of 6. Okay, let me rub this particular area here so that I can proceed with my working. So I'll end up with the following. So we are going to get, so we'll have t being equal to, let me use a different ink here. So my value of t will be equivalent to positive 9 plus or minus. So the square root of 81 minus 32, I'm going to get the difference will give me 49. So this will give me the root of 49. Then the whole thing is divided by positive 2. So this will be positive 9 plus or minus square root of 49. I'll get positive 7, then divided by 2. So this one means that either t is equal to 9, then plus 7, then of course divided by 2, which will give me 9 plus 7, I'll get 16, then divided by 2, which will give me positive 8. Or the other possible value of t will be 9, then of course minus 7, divided by 2, which will give me 9 minus 7. Of course, I'm going to get positive 2 divided by 2, which will give me 1. But the question did not want us to find the values of t. Instead, the question wanted the value of r. But there is somewhere we had already let r. We had said that we are letting r. Remember this equation, we had said that let r to the power of 3 be equivalent to t. Therefore, if I substitute back, r to the power of 3 was equivalent to t. So this one means that I'm going to get the following. Let me clean this particular area here. So it means that my value of r is going to give me the following. Let me clean this particular area here well. So we are going to get, so if r to the power of 3 is equals to t, it simply implies that our t, so it means that either r to the power of 3 is equals to t, but our first value of t, we got it as positive 8. So this one is positive 8. So it means that r to the power of 3 is equals to 8. So if we want to find the value of r, I'll take cube root on both sides and also cube root on both sides. So of course, r will be equivalent to, this will give me a positive 2. Remember the procedure for finding the cube root, you just take you type 3 on your calculator, then shift 3 shift, then this particular symbol, then you type 8, then equal sign. The answer, it is going to give you positive 2 as the cube root of 8. Then we also find the other possible value of r. So r cubed was also equal to t, but the other possible value of t, we got it to be positive 1. Therefore, r to the power of 3 is equals to 1. If you find cube roots on both sides, the cube root of 1 is going to give you 1. So r is also equivalent to positive 1. So those are the possible values of r. But remember, when r is equals to positive 1, this one simply means that your progression, that is your GP, the second term will be equal to the first term. Similarly, the third term will be equal to the second term. Therefore, such a geometric progression is not realistic. Remember, we are going to say that r cannot be equal to 1 since the GP, the geometric progression, will not be realistic. It will not be realistic. It will not be realistic. Why are we talking of not being realistic? Because remember, this one means that if the first term of that particular GP, for example, if the first term is 2, then the second term must be 2, the third term must be 2, the fourth term must be 2. So that when you find the common ratio, you'll end up with 2/2, which will give you 1. So, of course, this particular geometric progression is not realistic. That is why we are disqualifying r being equal to 1 as a valid solution. Therefore, we're going to conclude and say, therefore, the common ratio r must be equal to the positive 2. So our r, it must be positive 2. Because this GP will be realistic. For example, it could be, for example, 1, the second term could be 2, the third term 4, the fourth term 8. So that when you find the common ratio, you'll have 2/1 being equal to 4/2, being equal to 8/4, of course, which is equals to 2. Yeah, you can see this is a realistic geometric progression. That is why we are picking our common ratio to be 2 as a valid answer. Therefore, the common ratio r is equal to positive 2. Then we move to part C of the question. So in part C, we are being told that given that the 10th term of the GP is 5120, find A, the values of A and D. So we are told that the 10th term, remember that for any given geometric progression, we know that the nth term of any given GP is always given by the formula. The 10th term of the GP is given by the formula AR to the power of n minus 1. Therefore, the 10th term of this particular GP will be given by, the 10th term will be AR to the power of 10 minus 1. Then you are told that this particular 10th term is 5120. So this is 5120. So it means that, A, then of course, we already have the common ratio, which is 2. So we can substitute A into 2 to the power of 10 minus 1, we'll get 9. So this one should give us 5120. So it means that A, then of course multiplied by 2 to the power of 9. This one is going to give you 2 power 9. If you feed that on your calculator, you'll get 512. So this is 512 is equals to 5120. If I divide through by 512, I also divide through by 512. Of course, the value of A will be equivalent to 512 will go here 10 times. Therefore, our first term is equal to 10. Therefore, A is actually equal to 10. Then you also need to find the common difference of this particular geometric, that is D for the AP. So to achieve that, I'm going to use my equation Roman 1. Remember, this was our first equation. It was A plus D is equals to AR cubed. So I'll say using the equation A plus D. Remember, this was our first equation. A plus D was equal to AR to the power of 3. I can use this equation to find the value of D, which we haven't found yet. So this is going to give us the following when I substitute the values that I already have. So I'll have A. So of course we've found that A is 10. So this will be 10, then plus D. So this is 10 plus D should give us AR cubed. Our A is 10. Then of course our R, the common ratio, remember it was 2. Yeah, it is still here. The common ratio is 2, then to the power of 3. So this will be 10 plus D is equals to 10, then into bracket 2 power 3, you'll get positive 8. So this is 10 plus D, giving us a positive 80. Therefore, a D will be equal to 80 minus 10. So our value of D will be equivalent to 80 minus 10 will get 70. Therefore, our common difference is 70. So we've answered part C of the question. Then we'll move to part D of our question. Let me clear this particular area so that we can use it to perform our working. So in part D of the question, we are being told that calculate the sum of the first 20 terms of the AP. So in part D, they want us to find S20. We know that for any given AP, Sn is equals to n over 2, then into 2a, then of course plus n minus 1 multiplied by d, then you close the bracket. So S20, so the sum of the first 20 terms of the AP will be given by, of course, n will be 20 divided by 2, then into brackets 2 multiplied by a, which is the first term. Our a was positive 10, then of course plus n will be 20 minus 1 multiplied by the common difference. We got it as positive 70, then we close the bracket. So this will give us 10, that is 20 over 2 is 10, into bracket 2 by 10 is 20, then plus 20 minus 1 will get 19 multiplied by 70, then we close the bracket. So this will be 10 into bracket 20, then plus 19 multiplied by 70. If you feed that on your calculator, you'll get 1330. So this will give you 1330. Then this will be 10 into bracket 1330 plus 30, you'll get 1350. So this is 1350. Then 1350 multiplied by 10, you're going to get 13,500. Therefore, this is the sum of the first 20 terms of this particular arithmetic progression. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you.